Hello, everyone. A warm welcome to our World Quantum Computing Day. Today, we're going to have a couple of our experts in the quantum computing space talk to me and to understand a little bit more about what quantum computing actually is. Thank you both for your time today, Andreas and Stefan, and look forward to chatting to you. I do have to start off with my first question, and that question is, if you could imagine me as a child, could you please explain to me what quantum computing is? And Andreas, could I ask you to start off?
Yeah, hello Dylan. It's a pleasure for having me here today. So what is a quantum computer? Explained in easy words. It's a device which wants to utilize quantum mechanical effects. So what are these effects? These effects are always around us. They describe large bodies, as you or me, but they also describe small bodies, and that's where the full beauty actually will become apparent if you look at the properties and the interaction of individual building blocks of us. So this would be individual atoms or electrons or photons, and these items, they have very particular properties which are described by the quantum theory. So this is what we celebrate this day. And in these quantum computers, you are specifically utilizing these very special properties of these quantum objects for the purpose of computation. So if you consider a classical computer, which you have in your mobile phone or maybe on your work desk and so on, there you used currents of electrons, and they had different properties, which we call the bits, and they can be either 1 or 0. And in the quantum world, we talk about qubits. And I'm not saying all of the beauty of these objects yet, but this is our building blocks, which we are using. We call them qubits. And we want to isolate these qubits, and we want to interact with these qubits in a very controlled way. And then we can use them for computations.
Awesome. Thanks, Andreas. Okay, so to me, it sounds like we use qubits instead of bits, which is great. We might need to know a little bit more about those in a while. But before I get to that, I would like to understand, Stefan, if you could explain to me what really makes quantum computing so powerful.
Hi, Dylan, and thanks for giving me the chance to discuss these interesting questions with you. So it's a bit connected with what Andreas explained. In the quantum computer, we use this quantum mechanical effects of the qubits to empower our computer and do the calculations in a way which is not possible on a classical machine. So one thing is that a qubit can have many states at the same time. So a lot of them are, the more qubits you have, the more states you can process at the same time, which also means you can process a lot of data at the same time, and also the information can be shared in the link between individual qubits. So the more qubits you can connect, the more power you get into your quantum computer. So that's what's giving you power, the amount of qubits and how good they are connected. And with this, you can work on specific tasks where if you smartly use this quantum mechanical properties of the qubits, you can outperform classical computers. And that's the power of quantum computing.
Okay. So I think I understand. We have these super computers that are really much more powerful than what we call classical computers, which is the things that we know today. Someone like me, what I use. Okay, great. I guess my next question then is, if we have these super powerful computers, what can quantum computers be used for? And Stefan, can I give that back to you again?
Sure, that's a good question, because it's not like that they will outperform your classical computer on your day-by-day tasks, like adding up simple numbers or things like that, or just writing an email. So therefore you will never use a quantum computer most likely. But there are things, so the straightforward thing is, like, if you want to simulate a quantum quantum object like some molecules or something. Therefore, naturally, a quantum computer is a very advanced device concerned to a classical computer. But there are even things which are a bit more in our normal life, where they are better for some tasks to do them. That's the optimization of problems, like finding the best time schedule for trains at the train station, such that everybody has the shortest way and the shortest waiting time to get between their trains. Or for quantum machine learning, which means you shorten the time your machine learning needs to be trained by the help of a quantum computer. So in general, it's like tackling computational big problems with probably small data and using the properties of quantum computer to get it running fast.
Okay, I think I have a better understanding of what you're saying. So if I wanted to map out sort of the best trip around the world in the shortest distance or something, it would be able to give me the best way to figure out that trip.
Yes.
And obviously as a super basic example. Great. So my next question, and I think this question is going to be for you, Andreas, and that is, if we talk about quantum computer devices and that are available, could you tell me which ones that we could use today? So what is available today?
Yeah, that's a good question. And fortunately, there's a growing number of such devices which become available to users nowadays. They are very diverse, which is very exciting and interesting. And first, let me say there are different ways how you can build a quantum computer. We call them different technologies. It's basically the question, in which object can I find these isolated quantum effects? And there are different such objects where we can find them. There could be individual electrons. You can use individual atoms or an ionized version of this atom. You can use a photon. They also carry these quantum properties. And even these electric currents, which are present in our today's digital computers, can be quantized if cooled to very low temperatures. So you can either have natural objects which carry these quantum properties, or you can create such quantized properties. And currently all of these different ideas, they are actually pursued. So there is a large number of companies which explore the different technologies, try how suitable they are to build such devices, and what they can be used for.
Cool.
And there's also a different way of how one can do computing with these devices. This is a very detailed topic. Just saying, this is like speaking different languages. So these languages don't have quite the same letters. They don't have quite the same words. In the end, you will be able to express the same things you see in life and so on, but you would do it in slightly different ways. So these devices, they come with a different ingredients, and they come with slightly different languages, and therefore they are sometimes more suitable for one problem, and another device is then more suitable for another one. So currently there's a great diversity. It's a great field for exploring, and it's to be found which technology and which applications will be the most fruitful.
Great. Okay. Thanks, Andreas. So to me, it sounds like there isn't sort of one size fits all in terms of quantum computing. You don't have one device or one type of technology that is used for all these different use cases. We have different technologies within quantum computing, and they solve different problems or different scenarios. Cool, thank you. Another question, and for you, Andreas, again, following on for that, you talked about these different types of technologies that we use, but how are these devices used today?
So often they are used in a remote setup, so that you use our internet to connect to these machines, and then you can execute a computation on these devices. So they are bigger than our today's computers. They are more the sizes of a washing machine or maybe several of such. And then they have to be in rather controlled environments, like a computing center. But there they are connected to regular computers and to our internet. So you can just log on to these machines and write a computational script as you would do for your digital computer. So the way how you interact with these quantum devices is no different than you would interact with your digital computer. It's just that you have to adjust your language to this new device. So there are a few different operations available, and you have to become aware of how to use them. But then you interact with these machines as you would do with a regular computer.
Okay, thank you. Thanks, Andreas. I have probably just a couple more questions left, and this one is for Stefan. So when we think about all the awesome abilities and powers that we have within quantum computing, what would be interesting to know is what some of those challenges are that we're facing. Would you be able to explain that, please?
Sure. So, as Andreas said, there are many different technologies and all of them have different troubles at the moment, but you can generalize them to something like the problem all of them are facing without going into technical details of the things. And that's like the simplest and first thing is on the application side, we do not yet know what to run on them, where we really now see a benefit. That's something we should just test out, or maybe somebody gets a smart way to figure out which applications are the best ones for first testing. And then there are other things like the quality of the operations, which also means the possibility of errors occurring in your calculations is currently on the limit of usability, so to say. So often our applications are now limited by the amount of operations we can do before too many errors occur in our calculation, such that the result is not of any use anymore. That's one major blocking point for all systems at the moment, and there's a future target to get an error-corrected quantum computer, but that's something which is down the road. So there's still more work to be done. And the other problem is, which also necessary for this error correction, is scalability. So that means to be able to do error correction, you will need more qubits. That's true for all systems. And that means you have to increase your system size. And increasing the system size is technically challenging. As Andreas said, you have to isolate it good from everything. And the bigger your system gets, the harder it becomes to isolate it and still be able to control all parts on this atomic level. So the scalability is the other big challenge for the systems at the moment, where you have to figure out how you increase everything by keeping the same amount of control or even getting better, because you still have to get below the error rates.
Okay, so it seems that error rates are quite a big sort of challenge that you're facing today. Thank you so much for all of that insights that both of you. It's really, really interesting. And then for someone who's not that technical, I think I've got a bit more of an understanding about what quantum computing is. But I have started to notice recently, over the past few months, the hype around quantum computing come up a bit, and perhaps, you know, even in the news, I've heard some use cases of new quantum computers that have being created. I wanted to hear a little bit about what your opinion was of this. And Andreas, would you be able to start there?
Yeah, so for me, it's less than a hype. Then it's really like it's a new exploration and discovery, which we are starting. We don't quite know yet where this will lead us to. We cannot also say very precisely what the best applications for these new computational devices will be. But I think there is a lot of potential, and there is a lot of discoveries which we will make, and most likely we'll come up with solutions and applications which we did not have in mind when we started this journey. So I think this is what makes me the most exciting. that there is a lot of things to explore, and we have to just get going, get starting. And I think the hype is basically that we currently see a large increase in the community which thinks about quantum computing. It's not just these vendors which offer such devices, but people think about what can I use it for? How may it change my life in the future? And some are even interested in say, well, how can I actually get started and do my first computation on a quantum computer? And I think this is what the hype is for me. Like there are these devices, they are available. They become better with every day, but we have a large number of people who are focusing now on this new technology, and they want to explore its potential.
Thanks, Andreas. Stefan, I'm not sure if you would like to add anything to this, or if Andreas has covered it.
No, I would just maybe focus slightly on the hype topic. So if you look on these many people working on these many technologies since decades, most of them, you will see that there are really a lot of people seriously working on it, which are not just driven by the hype. So I'm also sure that there will be some fruitful results out of this big community. But as I said, you have to be aware it's currently a bit hyped. So if somebody tells you he has tomorrow the solution for all your problems in quantum computing, I would be a bit careful and just check what he's saying. But in general, I really think that it's a good community and they are able to solve these technical problems as I explained them.
Thank you very much. Thank you, Stefan. Thank you so much, Andreas, for your time today. I've really appreciated talking to both of you on this topic. I think I've learned a little bit more, and I hope that anyone else who's watching has also learned a bit more about quantum computing. Thank you very much for joining us today. See you soon. Bye-bye.
Thanks for your time. Bye-bye.
Engineering a smarter future together.